Hello students, welcome to Akshara 8 Foundation. So in the last class we have discussed about the optics of optics. In optics we have discussed reflection of light and properties of light we have seen there. Up to reflections and their types. So what is the reflection and what are their types? Okay, we have seen there. So now today we are going to see their types of reflection detail, and next we are going to see the remaining properties of light there. Okay, in the last class we have discussed about the 7 properties of light now. So in that we have discussed about the rectilinear property of light and reflection of light, and now in the reflection of light we are going to see here now types of reflections. Okay, so there are 2 types of reflections we have seen there. So in that the first one is what there, regular reflection. Okay, so we'll see here types of reflections. Types of reflections. So there are 2 types of reflections are there. So first one is a regular reflection. Regular reflection. Regular reflection. And second one is irregular reflection. Irregular reflection. So this irregular reflection is also known as diffuse reflection. Diffuse reflection. Diffused reflection. Diffuse reflection. And this one is known as a specular reflection. Specular reflection. Okay. So what is the regular reflection? We'll see now what is the regular reflection. Okay. So first of all we'll discuss about the regular reflection. So regular reflection is nothing but the reflection in which all the reflected rays also parallel there. See, whenever on the smooth surface, this, let us consider this is a smooth surface, and if the reflected rays falling on this surface like this parallel to each other, if the reflected rays are parallel to each other, and here at the point of incident there is a reflected rays, so the reflected rays will be emits there. Okay, so these are the reflected rays and these will be the incident rays there. So after the reflection in which all the reflected rays after reflecting from the surface are parallel to each other. Okay, for the parallel incident rays, so then that reflection is said to be the regular reflection. And here in this reflection the laws of reflection will be applicable. So all 2 laws of reflection will be obeyed here now. Okay, so that means here angle of incident and angle of reflection will be same, and this all normal and incident ray, reflected ray will be lie in the same plane. That is the laws of reflection, or those will be applicable. And this reflection, in other way also we can define this regular reflection or specular reflection. That is, if the reflection of light takes place from the smooth surface, then so this reflection takes place here. That reflection is said to be the regular reflection. Okay, the reflection in which this regular reflection it is almost takes place in the from the smooth surfaces. It will be takes place on the smooth surfaces. Smooth surface. Okay, on the smooth surface this regular reflection will be takes place now. So now second one we'll see here irregular reflection or irregular reflection or diffuse reflection Mostly this is it will be takes place on the rough surfaces. Suppose on the rough surfaces, if you observe the surface, okay, so then there are the irregularities will be there over the surface there. So it is like this, the irregularities will be present over the surface there. Okay, even if it is a smooth surface, if it is observed through the microscope, there are some irregularities will be appear there. Okay, so whenever the light falls on the irregular reflection for the parallel incident rays, but whenever the reflection takes place there, so all the reflected rays may not be parallel, they will be different. All the reflected rays may not be parallel there. Okay, So then all the incident rays will be parallel, but the reflected rays may not be parallel there. The reflection in which all the reflected rays not parallel to each other when they are reflected from the surface, rough surface. So that reflection is said to be the irregular reflection or diffuse reflection, and this reflection will be takes place on the rough surfaces. On rough surfaces, this reflection will be takes place. Okay, and here also the laws of reflection will be valid. That means angle of incident and angle of reflection will be always equal, and normal incident ray and the reflected ray will be lie in the same plane. They are known as laws of reflection. They are valid here. Okay, obey. In the both the reflections, laws of reflection will be applicable. Okay, so that is about the reflection. Okay, and types of reflection. So now we are going to see here next property of light, that is refraction. Okay, so we'll see now refraction. Refraction. Okay, refraction, the phenomenon of light, whenever the light travel from one medium to other medium, so it deviates its original path. So that the phenomenon of light is said to be the refraction. See here, so we can observe in our daily life, in a glass tumbler, if some amount of water it has taken, and in that water, if the lemon is placed, it is immersed, it is dipped in the glass tumbler with water. Okay, then what happens there? If you see outside of the glass, the shape of the lemon, it will be appear bigger in size. How? That is due to this phenomenon. Okay, suppose if any pencil or pen or any stick, okay, it is dipped into the water, then the part of stick or it is a rod, it will be appear like bends. Okay, actually it will not bend there, but if you see through the water, it will be appear like a bends, and it will be appear in the water, the part of the stick or rod which is placed in the water there. So how it will be appear? That is due to the phenomena of refraction. Okay, so we can see the stars will be during the night time we can see the stars. So they will be appear like the position of the star, lightning of the stars will be appear there. Okay, so that is due to the refraction of light. Okay, so now we'll see there. Okay, here the refraction, the phenomenon of light, whenever the light travel from one medium to other medium, so it deviates its original path and travel in other medium. So that phenomena is called as refraction. Okay, the phenomenon of light, the phenomenon of light, the phenomenon of light, the phenomenon of light which deviates its original path, whenever it travels from one medium to other medium, other medium. Okay, so is known as refraction, is known as refraction. So we'll show in the diagram there how it will be appear. Okay, so why it will be takes place? Because of the change in velocity of light. We know that light travels in the homogeneous medium, 3 lakhs kilometer per second. Okay, per second it will be travel 3 lakhs kilometers. So in the vacuum or in the air. So now whenever it travels into the other medium like water and glass, then the speed of light will be decreases. Due to that change in speed, the wavelength of the light will be changes, so that it will be bends and travel there. Okay, Suppose let us see here, this is a boundary which is separating the two medium. Okay, so let us consider this is the first medium and this will be the second medium. Okay, let us consider this first medium is the air and this will be the water or glass we can consider there. So let us consider it is the water there. Okay, water. So now this air is said to be the rarer medium. Two types of mediums we have there. We have discussed in the first synopsis about these types of mediums there. So rarer medium and denser medium. Rarer medium means what there? The density of the particles of the medium is less, is known as the rarer medium, and here the density of particles in the medium is greater. Okay, density and pressure. Okay, so it is a denser medium. Denser medium. That the density of the particles of the medium is greater, that is called the denser medium. Now, so here if you take normal at this point of incidence, you consider their normal. This is a normal. So n and m, if you consider their normal, then suppose let us consider the light is traveling from air to water, and here we know that this is a incident ray I bar, and the normal, the angle between the normal and the incident ray is angle of incident I, and it is the rarer medium and denser medium, first medium and second medium there. So now it will be bends towards the normal. So it bends, it is traveling like this. No, actually the path of this, if there is no, if the same medium is there, the path of the light will be, it is like this there. But because of this change in medium, it deviates from its original path. And it will be bends towards the normal. So this is called there. This angle is called there. Here angle of refraction. And this ray is called refracted ray. R bar. Now here the deviation. See, this is the deviation, the angle between the incident ray and the refracted ray. That is called the, here this is a total, this I know, angle of incidence. So this one we can write here I minus R. This is said to be the angle of deviation. So the phenomenon of light which deviates its original path whenever it travels from one medium to other medium there. So now it is traveling from air to water, rarer to denser medium. Okay, so then it deviates its original path, or it bends towards the normal. So and travel in the medium there, that phenomena is called as refraction. Okay, so due to this, the size of the lemon, it will be appear bigger than its original size whenever it is dipped in the water in a glass tumbler there. And the stick which is placed in the water, the part of stick, it will be appear bent in nature in the water. So that is due to this phenomena of refraction. Okay, twinkling of stars, that is due to the phenomena of this refraction. So during the sunset and sunrise, there is a actual sunrise. Okay, so actual place of the sun, it will be deviates because of this refraction there. Okay, so these all the natural phenomena will be takes place due to this phenomenon of light. Okay, so now next property, this is about the refraction, and next property we are going to see here, diffraction. Okay, next property is diffraction. So about this diffraction, now you can learn in higher studies. So there is a lot of there to learn about the refraction. Okay, so we can see in the higher studies about the remaining part. Okay, up to here, so we should understand the what is that phenomena and how it will be takes place. That we need to know. And there are the laws of refraction are there. Okay, so what are the laws of refraction is there, and so what happens when the refraction takes place there. Okay, of different physical quantities of light. Okay, that we are going to see and we are going to study in the higher studies. So now next diffraction. So here next property of light is diffraction. Okay, or diffraction. So next property is diffraction or diffraction. So diffraction of light. So diffraction of light is nothing but it is the The phenomenon of light, whenever it is traveling through the apertures, through the aperture or the edges, it bends at the edges and travel in its path. So that phenomena of light is known as diffraction. Okay. So whenever the light travels through the apertures, through the aperture or edges of obstacles, it bends at the edges or apertures is known as diffraction or diffraction. Diffraction or diffraction. Diffraction of light. Diffraction of light. Okay. So whenever the light travels, suppose any obstacle will come there, and whenever the light is traveling over the edges there, okay, it crosses the edge, or whenever there is a apertures will be there. Okay, it is a slits or like small slits. The light is traveling through the small slits or small apertures. So whenever it is traveling through those edges of the obstacles and the apertures, so at the edges, at the apertures, at the circular aperture, or it may be whatever the type of apertures or the slits. So around the slits and around the apertures, around the edges, it bends and travel there. So that phenomena of light is said to be the diffraction of light. That phenomena of light is known as diffraction of light. Okay. So about this detailedly we can learn in higher studies about this. Okay, in intermediate you are going to learn about, but here it is necessary to understand the phenomena of diffraction. And next property is there that interference. So interference of light. See, interference of light is nothing but, see, whenever two lights are coming from the coherent sources. Coherent source means what there? The source of light which emits the same frequency and wavelength of lights. So when they are traveling in the same direction, okay, so the overlapping of the two waves, the two light waves will be takes place. That phenomena of light is known as the interference of light, or we can say the redistribution of light waves, redistribution of light waves takes place when the two coherent sources of light, okay, when two coherent sources of light waves traveling in the same direction, okay. So redistribution of the light waves takes place when the two coherent sources of light waves traveling in the same direction. That coherent source of lights are nothing but the sources which emits the same frequency and wavelength of light which they emit. So that waves are traveling in the same direction. The overlapping of two waves will be takes place there. So whenever the overlapping of two waves will be takes place there, there is a vanning and waxing will be takes place. Vanning means further there is a at whenever the two waves means there are light waves are the transparent waves, crest and troughs will be there. There two troughs or two crests are overlap each other. There the bigger amplitude of the wave will be appear, and whenever the one coherent and the trough are overlaps each other, there the minor zero amplitude of the light wave it can be seen there. Whenever there the two crest or troughs are overlap each other, the bright light can be seen there, and whenever the crest and trough are redistributed or overlap each other, there we can see the dark light there. Okay, so like bright and dark lights we can observe there whenever this interference of light will be takes place there. So that is called the interference of light. Okay, this phenomena of light. The phenomenon of light redistribution of the light waves takes place when the two coherent sources of light waves traveling in the same direction. So that phenomena is known as the interference of light. So next one we are going to see here polarization of light there. So polarization of light is nothing but polarization of light is, so there the light has the light is the electromagnetic wave. So there is the electric field and the magnetic field will be there. So in its propagation, when the light wave is traveling in the medium, so there are the light waves and magnetic waves will be present in it. Okay. So then in the polarization of light there, so it will be electric field vector. So whenever it passes through certain mediums, that medium it separates the electrical waves. Okay, it separates the electric field vector. So that phenomena of light is said to be the polarization of light. Okay, so polarization of light we'll see there. Polarization means simply separation of separation of the objects. Okay, here then what it separates there? It separates the electrical vector in the light wave. Okay, so only some amount of means some intensity of electrical wave it can be separated from the loss whenever the light it is passing through the medium. So particular medium, what will happen there? The intensity of light will be decreases due to the by stopping the passing of electrical vector through that medium there. So that what happens there? Then only the intensity of light will be decreases. Only magnetic vector can be come out from that medium, so that the intensity of light can be decreased. Okay. So that phenomena of light is said to be the polarization of light. So polarization of light. The phenomenon of light. The phenomenon of light. The phenomenon of light. Light. In which electric vector can be separated by crystals, by a medium, otherwise by a medium, so the intensity of light decreased, intensity of light is decreased is called polarization of light. This separation okay, is known as or grouping of light is known as polarization. Light is called polarization of light. Okay. The phenomenon of light in which the electric vector can be separated by the medium. So the intensity of light is decreased is called polarization whenever it passes through that medium. So when it passes through the medium. When it passes through the medium. When it passes through the medium. Okay, this is called the polarization. Suppose, let us see here certain type of crystal. Let us consider this is a crystal there. So now through this, this is a light vector, no? Okay, to understand this, to understand here, the light, in the light electromagnetic wave, there are two field vector will be there. One is the electric vector and other one is the magnetic vector. See here, these two are considered as the electrical vectors, and here the magnetic vector will be there. So now here some electric vectors can be here. This dotted part will be represents the, like this whole vector, this whole field of light vectors, it can be represented like this. Light will be traveling in all the direction, no, whenever it passes there. Okay. So now this remaining all the vectors are denoted by here dot. Okay. Only these two vectors, perpendicular vectors, are treated as here electrical vectors, and remaining are the magnetic vectors. Okay. Perpendicular vectors. So now this, whenever this amount of light is made to fall here, whenever it is coming out from this, so then only the magnetic vectors can be come out there. Only the magnetic vectors which are perpendicular to this crystal, okay, perpendicular to the medium. So here that phenomena of light. So this is called the polarized light. This is called here unpolarized light. So this is unpolarized light. Unpolarized light, and this is called here polarized light. Polarized light. Polarized light. Okay. So means whenever some amount of electric field vector is separated from this light wave, then the intensity of light will be decreases. So less intensity of light will be passes through that medium there. So this the light which is the medium which separates this some amount of electrical vectors from the light. So those are known as the polarides. This is called the polaroid. The crystals polarides. So these crystals are known as the polarides here. Okay. So whenever it passes through that, these mediums are used as a cooling glasses. So we'll use the goggles now. So in the goggles, these polarides will be placed so that the intensity of light will be like they will be used as a sunglasses, no, sun goggles. So then the intensity of light will be decreased, and so it can be protected. Our eyes can be protected in the sunlight. Okay, so that that will be takes place due to this polarization of light, phenomenon of polarization of light. Okay, so that is about the polarization of light. Now we are going to see here, based on these properties of light, here some of the questions are given there in practice sheet, so that we are going to see now. Okay, so here practice sheet 2, we'll see the practice sheet 2 now. Okay, so concept based questions are there here. See here, practice sheet of practice sheet. So now first one we'll see here, the phenomenon by which incident light falling on a surface is sent back into the same medium is known as. The first one is reflection. Okay, reflection of light is what? Whenever the light is fall on the surface, so the light, it will be reflect back. It will be bent into the same medium. It will be comes back into the same medium. That phenomena of light is said to be the reflection. Okay. And second one is here, an object becomes visible when the light undergoes dash reflection. Okay. Whenever the light can be seen there, when it will undergo so a reflection. Which type of reflection there? Regular reflection, irregular reflection, diffuse reflection, normal reflection. Okay. It is the regular reflection. Whenever the regular reflection takes place, then we can see the objects properly. Regular reflection. Regular reflection. And third one, the photoelectric effect was invented by. And next, one more property is there. I forgot to tell here. Photoelectric effect. Okay. Next property of light is photoelectric effect. Photoelectric effect. So photoelectric effect is nothing but the phenomenon of light. The phenomenon of light in which the emission of electrons will takes place from the metal surface whenever some amount of light is made to fall on the surfaces. So that is called the phenomenon of photoelectric effect there. Okay. The phenomenon of light, phenomenon of light in which the emission of electrons takes place when certain frequency of light is made to fall on the metal surfaces is called photoelectric effect. So this photoelectric effect was, it was invented by the scientist Einstein. So Einstein was invented this photoelectric effect there. Okay. So here the third question is asking there. Suppose it is a metal surface. No, this is a metal surface. On the metal surface, if certain frequency of light is made to fall here, then emission of electrons will be takes place there. This electrons will be comes out from the metal surface there. So that phenomena of light is said to be the photoelectric effect. Okay. So now here they are asking there. This was invented by the scientist Einstein. The photoelectric effect was invented by the scientist Einstein. Okay. So here it is invented by Einstein. Okay. The photoelectric effect was invented by Einstein. The next fourth one, the shadows are formed due to the characteristics of. There is for the rectilinear propagation of light. So fourth one is rectilinear propagation of light. And fifth one, interference phenomena established that light coexists of waves, particles, rays and photons. It is a waves. So whenever the two waves, here the coexists of waves. It is coexists of waves. Okay. And next, diffraction. Diffraction is a dash phenomenon of light. Natural phenomena or artificial man-made superficial phenomena. It is a natural phenomenon. Okay. So natural phenomena. Sixth one is natural phenomena. Okay. And seventh one, the light travels in a dash path, in a rectilinear path. Seventh one is a rectilinear path. Light travels always in a rectilinear path. rectilinear path. Okay. So emission of electrons when light requires frequency falls on certain metal is called there. The emission of electrons, that is called the photoelectric effect, that we have discussed now. The emission of electrons takes place when certain amount of frequency of light is made to fall on the metal surface. So then that is called the photoelectric effect. Photoelectric effect. Photoelectric effect. So is called the that is called photoelectric effect there, emission of electrons. So now exercise problems we'll see here. Understood now these concept based questions. So now we'll see the exercise problem, exercise bits. Okay. So now exercise. First question is given there. The phenomenon of diffraction of light was discovered by. Okay. The phenomenon of diffraction of light was discovered by Fresnel, scientist Fresnel. Okay. So in the exercise 1, Fresnel. So Fresnel is a scientist. He has discovered about the phenomenon of diffraction of light. Okay. So next one, the light wave can be polarized as they are. So as they are transverse waves. Light is a transverse wave. Okay. Here high frequency longitudinal reflector is given there. They are the transverse waves. Okay. So transverse waves. So next one, when the light is entering from one medium to other medium, it deviates from its original path is called as refraction. That phenomenon is said to be the refraction. So whenever the light travels from one medium to other medium, it deviates from its original path is called the refraction of light. There. Okay. So next one we'll see here. Photoelectric effect was invented by, already we have said there, Einstein. Okay. It was invented by Einstein. It was invented by Einstein. So next one, during dash there is no loss of energy, reflection, interference and polarization, total internal reflection there. In total internal reflection, there is a total internal reflection. One more concept is there in the refraction topic. We can discuss that one in higher studies. So total internal reflection. Okay, and sixth one it is given there. The shadows are formed due to the characteristics of propagation of light, rectilinear propagation of light. That is, already during the refraction, which are the following characteristics of the light changes. So whenever the light travels from one medium to other medium, wavelength and velocity of light will be changed there. Okay, wavelength of light. So seventh one, wavelength of light and speed of light will be changed. Wavelength and speed of light will be changed. Okay. So frequency is constant and phase angle of the medium light wave is constant there. The diffraction effect can be observed only sound waves, only light waves, only ultrasonic sound waves as well as the light wave. Only light waves. For the light waves only the diffraction of the light can be seen there. Okay. It is for only light waves. Option 2. Eighth one is option second one. Only for the light waves. And here ninth one, the phenomenon of interference is shown by. The phenomenon of interference of light wave is shown by longitudinal mechanical waves only, transverse mechanical waves only, electromagnetic waves only, all the above type. So even now, in the longitudinal waves also interference will be takes place. There is a sound will be seen there. Okay. So all the electromagnetic waves we can see there. Okay. And 10th one is given here, the penetration of waves into the region of geometrical shadow is, okay. The interference, diffraction, polarization or dispersion. So that is the penetration of light, means it is bends, penetration of light in the region of the geometrical shadows. That is called, that is a diffraction. Due to the diffraction only it will be bends, and there is a shadow will be formed. That is due to it is diffraction only. So the phenomena of bending of wave without changing the medium is called there. Phenomenon of bending waves without changing the change in medium is called there. So there is a refraction. Okay. The phenomenon of bending waves without changing the medium is called their refraction. Okay. The light shows random propagation, curvilinear propagation, rectilinear propagation. It shows the rectilinear propagation in a homogeneous medium. We can see the things around us due to, so that is due to the regular reflection of light. There. So next question, the parameter which remains constant on refraction is, okay, that is the frequency of light there. Frequency of light. So which are the following phenomena established wave nature of light? So wave nature of light is established in diffraction. Diffraction and polarization. Even in the, okay, all of these in interference, diffraction, polarization, in all of these, the phenomenon of light, nature of light will be wave nature of light. It will be appear. So when light enters into a medium and changes its path, the phenomena is called there. So when light enters into a medium and changes its path, that is called there. And reflection is given, both of these, none of these. So it is a refraction there. In the refraction, it changes its path. Okay. And the bottom of tank appears to be a concave due to. So there is refraction of light. Due to the refraction of light, it will be appear like that. A light wave enters from air into the glass, then the following are affected: velocity of light and frequency of light. Only the velocity of light will be changes there. Okay. So then the interference of light was demonstrated by. So interference of light was demonstrated by Thomas Young. Polarizer is used to reduce the intensity of light there. Okay. It will be reduces the intensity of light there. The twinkling of star due to the mechanics. So that is, I explained now in the explanation. The twinkling of star due to the refraction of light. Whenever we see the stars during the night time, they will be twinkle, no? The blinks, the stars will be blink there. That is blinking or twinkling is due to this the phenomena of refraction of light. So this is about the synopsis 2, and next one we have here. So synopsis 3 is there. It is about the developmental study of light there. Okay. So during the nature of light, actually the nature of light has two types. Okay, that nature of light, this whole optics is based on different natures of light. Means what is the nature of light? Whenever the scientists are finding the reason for that, they are finding the studying about the nature of light there. So there are different scientists. They have explained the nature of light differently by using their different theories. So in that first one is Newton has explained. So that explanation, that theory is well known as Newton's corpuscular theory. There. Okay. Then after Huygens came there and he explained about the wave nature of light there. Okay. Then Maxwell's will come there. He explains about the quantum. Okay, quantum theory. Then later de Broglie has came here. So then he explained about the dual nature of light there. So means light will be exhibits both particle and wave nature. So when it encounters, it will be based on the medium which through it is passing there. Okay, so based on that it will be there. So now here, so the development study of light in the different periods there, that about that it is said there. Okay, so first law, first Newton has explained about the corpuscular theory of light. So in the corpuscular theory of light, what he explained there, the Newton has explained there like that the light will be travel in a tiny particles. The tiny particle is he named as a corpuscular. Okay, corpuscles means small packets of light, small packets, tiny particles of light there. And he explained that they will be travel, okay, in the rarer medium. So speed of light will be greater in the denser medium and lesser in the rarer medium. He explained there. Later by Huygens it was proved that it is wrong there. So there are some merits and demerits are there in that theory. Then Huygens explained, okay, about the wave theory. So he explained the wave theory by using the wave fronts. Okay. So wave front is nothing but the locus of all the particles of the medium which will be in the same phase of light. Okay. So they are known as the wave fronts. So about that wave front, by using the wave front, the I can explain the wave theory of nature. It also has the merits and demerits. So then it explains about the reflection and refraction phenomena successfully in the by using the waves, but it does not explain about the interference. It does not explain about the polarization. Okay, it explains this interference also, but it fails to explain the diffraction and polarization. So later Maxwell's electromagnetic theory. So he given the Maxwell's explained about the electromagnetic wave theory. So like there are different electromagnetic waves are there, like microwaves, radio waves. Okay. So by using that he explained about the wave nature of light, and that also explains all the properties of light except the photoelectric effect there. So next Planck's quantum. Okay. Max Planck he has explained about the quantum theory of light there. So in the quantum theory of light he explained that the light travels in a small energy packets. That energy packets are called as quanta. So every quanta has its energy there. That energy equation is given, E is equal to h nu. Okay. So by using that he explained about the this one photoelectric effect, but it is failed to explain about the polarization of light. Then afterwards Einstein's quantum theory there. Einstein explained. So by the help of this quantum theory, he named as the small energy packets as a photons. So it is Einstein's photon theory. It is well known as the, and it is explained now this photoelectric effect successfully. So these are the history of study of light. So different scientists they have explained differently nature of light there. So finally they have concluded that in all the theories they concluded the light has both nature, dual nature. So whenever it encounters the some medium, based on that medium light will exist both particle nature and the wave nature. Okay. Here we have the some conceptual questions are there. We will discuss that. Then we can conclude this chapter. Okay. So in the next class we are going to start the next magnetism chapter there. Okay. Now here the first question is given, concept based questions. See here the theory which nature of light depends. The theory on which nature of light depends there. So wave theory, particle theory, both wave theory and particle theory, only one it is given there. Okay. So the theory on which nature of light depends. Okay, nature of light. So nature of light it depends on the wave nature and particle nature, both 1 and 3. Okay. So it is, the answer is, correct answer is what, the wave theory. So second question is given here, why light is said to have a dual nature. So why light is said to be a dual nature of light there. So it exhibits, first option is given there, it exhibits the property of wave and particle, it exhibits the properties of reflection and refraction. It has both interference or polarization effect, none of these. So because it is exhibits particle nature and the wave nature, so the light has both particle and wave nature, that is called the dual nature of light. So third one is given there, Newton's theory of light is also called as corpuscular theory. Corpuscular theory. Corpuscular means small energy, tiny particles of light. They are known as corpuscles. So corpuscular theory. Newton's corpuscular theory. So next one, according to Newton, light consists of a stream of dash Moss particles there. Okay, tiny moss particles there. Tiny moss particles. So next one is given there. According to Huygens theory, light is a dash mechanical wave there. Okay, it is a transverse mechanical electromagnetic wave there. So transverse mechanical wave. Transverse mechanical wave according to this Huygens. And next one, according to the corpuscular theory, light should travel. So dash in denser medium than the rarer medium. Okay. So slower in denser medium than the rarer medium there. Okay. Sorry, it is faster in denser medium. So faster in denser medium and slower in the rarer medium. According to the that is proven that it has wrong there. Okay. So later Huygens was proved that it will be wrong. Next exercise problem here, it is given. The phenomenon was explained by corpuscles with the surface on which the light is incident. The phenomenon was explained by the corpuscles when with the surface on which the light is incident. So there is reflection. So in the reflection, the Newton corpuscles theory has explained successfully of this reflection and refraction there. So it is given here. The first one is reflection. The speed of light is dash in denser medium. Speed of light is less in the denser medium. Electromagnetic wave travel through a medium lesser speed than the speed of light, more speed than the speed of light, more speed of light depends on the medium there. Electromagnetic wave travel through a medium which depends on the medium there. If it is a rarer medium, then it will be travel with the speed of that means rarer medium means particularly air and vacuum there. Okay. It will be travel with the speed of light. In denser medium, it will be depends. It will be decreases then. So according to Huygens wave theory, whole universe is filled with the hypothetical medium is called the ether. Okay. So he explained about Huygens has explained about the mechanical waves. So wave means wave it has to be travel means certain medium has to be present there. Without medium. In that time there was no non-mechanical waves there. Electromagnetic waves are not introduced. It was introduced by the Maxwell's. Okay. So then he has assumed that throughout the universe there is a medium is called the natural medium, that is called the ether. So in that medium the light will be travels. So like that he assumed there. So that medium is called the ether. The idea of quantum nature of light has emerged in an attempt to explain. Okay. So to explain the idea of quantum nature of light was emerged to attempt to an explanation of radiation of spectrum of black body. So radiation of spectrum of black body to explain that this the idea of quantum nature has emerged. Okay, next one, the wave nature of light is verified by. Wave nature of light was verified by. So interference of light, photoelectric of reflection and refraction there. Okay, wave nature of light was explained by this interference of light. Okay, and by the Huygens wave theory, the light cannot be explained the phenomena of photoelectric effect there, even the photoelectric effect. Okay, so it couldn't explain about the photoelectric effect there. Okay, so now according to dash theory, the light consists of a stream of tiny particles. There is the Newton's corpuscular theory. Newton's corpuscular theory there. So in Planck's quantum theory, electromagnetic radiation are emitted or absorbed matter in small discrete packets are called as. Okay, it is a quanta. Okay, small tiny particles. The Max quantum explained that the light will travel in a small energy packets that are called as quanta. So which of the following is conserved when light travel with light waves interfered? Which of the following is conserved there? Intensity, energy, amplitude and momentum. So energy is conserved. Newton postulated his corpuscular theory of light on the basis of Newton's rings, color of films, rectilinear propagation of light, dispersion of light there. So that is the rectilinear propagation of light. So Newton's theory explained one of the following phenomena. So refraction and only refraction. He has explained the refraction properly, but remaining phenomena could not explain there. Okay. Next, according to Newton's theory, the speed of light is more in rarer medium, more in denser medium. According to Newton, the speed of light will be more in the denser medium, but it was wrong. It has proven wrong there. Okay, later. According to Newton's theory, the speed of light is more. Okay, that is over. Electromagnetic waves are transverse in nature. Electromagnetic waves are transverse in nature. Then, in which of the theory propagation of light takes place by the advancement of wave fronts? Okay, in a wave theory. Okay, wave front. So wave front is constructed by using the wave fronts, the reflection and refraction interference. Okay, this was explained by using that wave theory by the Huygens. Okay, according to the wave theory of light, existence of medium is completely hypothetical. So that is ether. So that is called the ether there. Okay, hypothetical medium it was introduced there. So Dash proposed the electromagnetic wave theory. Electromagnetic wave theory is proposed by the Maxwell. Scientist Maxwell has proposed this electromagnetic wave theory. According to Maxwell's electromagnetic wave theory, light propagates as a electromagnetic wave. So light travels as an electromagnetic wave there. Okay, so that is called about the history of study of nature of light there. Okay, this is different theories are explained about the nature of light differently by their nature, and those studies are explained some of the phenomena, but altogether they concluded that the light has both particle nature and the wave nature. So based on the light encounters the medium through which the light passes there. Okay, so this is about the optics chapter we have completed. So in the next topic, in the next class, we are going to start the magnetism. Okay, understood, children? So thank you, children. Have a nice day.